recording. So, important things. We're back here in Unity. I'll just recap for just 2 seconds. We're back here in Unity. We have a game manager object, which has a game manager script on it. If I double click on it, opens up Visual Studio, and you will see our game manager script. And yesterday, or Tuesday, sorry, not yesterday, all we really had was this kind of start function that had sort of a hello world that would print in the console window, right? So print is a debug log that shows in the console window. And we did, I'm not sure, some of this might be left over the afternoon, AM, PM, who knows. But we did some basic math. We printed out some values. Like here, I called an add function, and it added x plus y, and this x and y were some private variables here inside my class, and so on. So basic stuff. Now, before I really explain the code, let's see it in action, because we'll sort of be explaining it as we go. So we also talked a little bit about the canvas and how we're going to have buttons and heads-up display items and control items. And the game that we're going to develop, our first game, is going to be based on these UI elements. And we're going to be communicating with the player, user, through the UI, right? We're not going to worry about stuff in the world yet. We're going to be doing it all kind of through the UI. And I'm still gesturing as if you can see me on the screen. I wish you could, yeah, whatever. Okay, so looking at this UI here, I have a little canvas, and I have a text box, right? In this case, now I'm using full-fledged Text Mesh Pro to draw this, and I have some buttons. I have button 1, and button 2. And if I press play, my goal was to actually show a little bit of programming and logic. You may have heard did you hear the boink boink? Did you hear the audio? Yes? Oh, I'm thumbs upping and you can't see me. All right. So I have text on the screen. It says new text. If I wanted that text to change, I could go back to my script, and this is, I'll show you the goal as opposed to the code just yet. All right. So imagine we had a calculator, right? We're talking about programming. You may have had a programmable calculator. Who knows? And most of the operations we've talked about so far have been simple kind of arithmetic operations, addition, subtraction, multiplication. We talked about how to do those sorts of things. So I've created some buttons down here, and this is a very poorly designed calculator, right? We can flesh this out and add more buttons, add more functions, add so on and so forth. This is really an exercise. And if you want to use some of this in your game, expand on things, or in future heads-up displays, that'd be awesome. So, but for now, I have this button here, and I'm going to press that button. You see it says 1 up here because I pressed 1. And now, if I press plus, you'll see it says 1 plus up here in my text message. So my intuitive sense would say, well, I want to add something to that, so I'm going to press 1 again. All right, 1 plus 1. So 1 plus 1, and now my intuition would be that I should press equals, right? So equals, and I said, 1 plus 1 equals 2. All right, pretty cool. And this is a really dumb calculator, but what if I pressed plus 1? All right, equals, 2 plus 1 equals 3. And I say plus 1 again. 3 plus 1, all right, equals, 3 plus 1 equals 4. And then I'll try to challenge it, and I'll do something like this, and it will not do the right thing. It'll just say, well, 4 plus 1 equals 5. It sort of, it's like, oh, okay, I'm not that sophisticated yet, but I could be. I could get real fancy. 5 plus 1 plus 1 plus 1 should be 8, but instead we could just get 5 plus 1 equals 6, because we're talking about a very simplified calculator here. Now, you could expand on that, and we'll look at that as we actually kind of get into the sample. There's not a huge amount of code behind here, and some of the magic lies in the Unity interface, taking care of lots of clicking on buttons and so on. The script that is in here, and I'll flash it on the screen right now, so if you do want to come back, mark the time, a few minutes into class. Where are we? It's all in the game manager, so the hint here is that, yes, our first game is largely going to be a single script that we're going to be having a bunch of functions in here that we're going to connect to UI items, and then they're going to communicate with the user interface to kind of let us know what's going on. So there's really just two operations that happen in this script that are important. There's two events depending on what type of button you click. So there's a my click, which is when you click on ultimately if you click on a number, this happens. Maybe I should name that on operator click. And there's another button which is on operation, and we have a plus and we have a minus, and that's what's going on down here. We have this, okay, if I pressed plus, this little bit happens, and if I pressed equals, this little bit happens, right? So we're going to see a little bit about how we can check a condition, and then we have a little bit of some conditions, some really simple ifs and assignments, and some basic interfaces to our Text Mesh Pro. So it's really, what do we have? 20 lines of code-ish, plus parentheses and a little formatting here, right? And if I wanted to flesh out my calculator, I likely wouldn't even have to write much more code to make it much more interesting than this. And to prove that, let's see, let me prove that here. All right. So you shouldn't be setting out to write lots and lots of code. So I'm going to go over here and I'm going to take this button here. I'm going to press Control D, and I don't see anything happen because it just duplicated that button exactly in the same spot. I'm going to put this over here. Okay, new button, and I'm going to put some new text on that button. And the next part, this is the mind-blowing part is here. I need to tell the button a value to pass my code, which is going to be this 2 down here, and we'll do that in a second. All right, let's see if it worked. I haven't changed any code yet. I'm just adding Unity objects that are going to interact with my components. So let's see. 1 plus 2 equals 3. Okay, didn't change a single line of code. I only changed what was going on in the UI, right? So it's always going to be back and forth, kind of balancing how our design is implemented in our code there, right? Something more sophisticated like adding division or subtraction or something like that, probably gonna need a little bit more code behind there. So that's what we're gonna set out to do, and it is just a few lines of code. All right. So let's go back and come back to here and kind of take off where we left off. So we left off, oh wow, I'm gonna shoot through all of these things. We talked about classes, we talked about structs, we talked about the differences of coding inside something like an engine versus just writing an application in C#, which we're not gonna do. All these boring things. We had obviously important stuff like assigning things. We had variables and how to assign things to variables. And we talked about scope, right? So we have things that are private to classes, things that are potentially public. We talked about our basic operators, our arithmetic, our relational, our logical operators. We took a quick look at conditionals, right? This conditional code execution. If something, do this, else do something else, right? That should be a cool concept. I believe we got to the unary operators, which are just kind of shortcuts to other operations, just quick ways to say, C plus 1 equals, C equals C plus 1, C equals C minus 1, that sort of thing, right? Ternary operators, we're going to leave bitwise and bit shift operations to really talk about for later, but the main thing to remember here, of course, is that ampersand or the and the bar or the or, these things are reserved for bitwise operations, as opposed to when we want to do logical operations, we did the and, right? That means this and that is a double and this or that is a double bar here, okay? And are much less than, much greater than are really bitwise operations as well, which we'll leave for later, all right? Compound assignments, also shortcuts. Basically, they're ways to, so you don't have to say this plus this equals that. You can say this plus equals 2, and so on, right? We good? We remember these things? I'm not hallucinating. We did talk about them on Tuesday. You get some thumbs up? Any surprises yet? No thumbs up. I'm not getting any thumbs up from anyone, so can you hear me? Okay. Or am I forcing you to say, yes, we did these things? Now, important thing, we may occasionally need to convert values from strings to integers and integers to strings and so on, because sometimes we want to add numbers, and to do that we need mathematical operations to do that. But to communicate to the user, we may need these things to be in the form of strings so that they make sense, so we can read them. Okay, remember that. We're going to do that. Now, okay, so that largely should have brought us up to programming in C# and Unity part 2 for today, and there's just going to be an expansion on our conditionals, or if-thens, or if-elses, and introduce some concepts about loops and so on. Right? So if you want to get really, really fancy, and we may choose to implement multiplication via a loop rather than doing multiplication as in multiplication operation. So that would be something we do in our calculator. We're going to do it the hard way. We like to start off doing things the hard way just so we can kind of see how they work. So our favorite conditional, of course, is good old if-else. Right? If this, do this, else do that. Right? You think much of the decisions you make in life, you've sort of been, presented, usually you have two, maybe you have more than two choices. And even in that case, we can use if-elses for those as well. But it is the basic, most flexible conditional in C#. The else is even optional. You can just say, okay, there's only one thing you could choose, and it either is or isn't. There's no otherwise, right? So if daylight is true, do this stuff, and there's no operations otherwise. That could possibly happen. But we might have more complex things where we're using more if statements to create these complex executions or compound if statements. And not only can we have lots of options, but we can also nest these ifs and elses inside of one another, right? So that basically creates these sort of, okay, if this and this, that means one thing. But then, even in that case, we might have some more decisions to make, right? So these are all about decisions. So for instance, here's a not a super complicated, but a reasonably, we're starting to get complicated. Say, okay, we have a daylight variable, which is a Boolean. We're going to say it's either day or not. And we have is night, which is either day or is true or not, which you might think is weird, right? It's either day or it's night, right? One of those are there. But what about twilight? Is twilight day or is twilight night? We don't know, but we're not going to have another is twilight, so we'll just, and it's not the movie Twilight, because that's a whole nother thing. So I mean twilight like evening time or just before the sun is really up, the golden hour, and so on. Okay, so if daylight is true, so there's enough daylight out, it's beyond dawn, we play the happy music. All right, and this would be the first thing that happens. And these are else statements. So if it is daylight, none of these other things will happen because these are elses, right? These are only in reaction to whether this happens or doesn't, right? Starting off. Now, if this doesn't happen, we're going to continue on down here. So if it's not daylight, we're going to do all this stuff down here. So daylight is sort of an absolute. If daylight is true, or is daylight is true, we play the happy music. If it's not daylight, we check, okay, here's the next thing to evaluate. Else. We just do this in linear order. We say else if is night equals true, well, we play the cricket and owl sounds. Okay, so we're in one case or the other, right? If this is true, we did this. If this is true, we did this. Now, the only other condition would be what? It's not an or. It's basically a neither of these are true, right? So this would be if both of these were false because it didn't come in here, it wasn't true, and this didn't happen because that wasn't true. Now we have that neither day nor night, so we must be in that kind of twilight, sunset, who knows, kind of sort of thing. So there we play our ominous sunset music, and we're going to assume twilight is sunset. Oh well, there's no. We always play werewolf games in here. So we play the ominous sunset music, but then we also might have a condition inside of here where it's twilight, and yeah, during any of those times it's twilight, but only one day out of the month is it actually the full moon. Right? So even though these two things are false and we're in here, we might have yet another condition, right? This nested if statement, which runs if both other conditions were false, right? We had to get through this point where both of these were false and is full moon is true, right? So if it's twilight, basically because of these two, and the full moon, we play the werewolf howling sounds, right? So once a month, we get the werewolf to happen. Everybody follow that one? Not the most complicated if-else, but reasonably demonstrates the point. Now, if we had to do that all the time, and we have lots of conditions, and let's say we have 7 days a week, right? And we have a different condition for every day of the week. You can imagine something like this would get a little bit tedious. If it's Monday, do this. If it's Tuesday, do this. If it's Wednesday, do this, and so on. Or get a little bit tedious. So we have a different case, pardon the pun, a different case called the switch statement. All right, so a switch statement basically allows us to combine or encapsulate a bunch of different if statements kind of in here. We have, say a number specific things here that we want to work with. Now, we're sort of limited in terms of what these things can do. We can't have, complicated conditionals in here. It's basically just going through and saying, well, if it's equal to this, do this. If equal to that, do that. If equal to this, do this. Turns out to be a very, very, very important thing, because you can imagine, you could say, okay, what is my state as a game object? My state might be hunting. My state might be fleeing. My state might be waiting, right? So you can do all sorts of things to say, okay, let's use a switch statement to jump through, one of these states, or figure out, okay, what state should you be in, and therefore do that, right? So that's these are very cool for that sort of thing. Or even like, well, what if I had a particular type of enemy that I was interacting with? Is it a vampire? Is it a werewolf? Is it a zombie? Is it a mummy? Right? You might have some sort of identifier here for each of those types and say, okay, I'm going to react according to the type that I saw, right? So you have switch num, and again, this should be a equality comparing to a literal here. So normally we see these things just integers. So num is 3 in this case. It's kind of a very contrived. It'll never wind up being 3. But if this was the case, we'd say, okay, switch num. So then it starts the comparison. It says, okay, num is 3. And the case will tell us which one. Okay, case 0 is num 0. Nope, num is 3. So don't do this stuff. Case 1, nope, not that one. 3, okay, vampire. All right, so therefore it's the vampire. I need to take the vampire action, stake the vampire, do whatever it takes. This is just a comment. This is just pseudocode. So that would be the course of action I would take by switching on this. This would be the particular case of this switch. The other piece of it you see here is this break, right? So each of these will have a break for the case ending, right? Case should end with a break. So after each one, it's sort of like, it's not like a return where it ends all the code. It just ends this statement. So there should be a break in here. What happens if you leave out the break? Well, if the case has no body, execution will fall through to the next case. Otherwise, you get a compiler error. So what I mean by that, maybe zombies and mummies you do the same thing for. So zombies and mummies are both, here's zombie 5, mummy 6. So we're going to treat them the same, right? They might have the same operation for them. Some languages will let you get away with doing things like, we'll have a little bit of code in between here and then fall through. C# isn't one of those, right? You'll get an error if you try to put some code in here without a break in there. And there's also, can't quite see there. Oh, I got cut off. Oh, no, it's all there. Default. You can have a default statement where none of these are the case. And so, okay, I encountered a monster I have no idea what to do with. You can have that action at the bottom of your statement, okay? So switch case statements, important stuff. Now, those are not loops. Now let's talk about loops. Something you want to have happen over and over and over again, you want to do that generally in a loop. We're going to have loops that are occurring without us even knowing it in Unity. Things like, the update routine that gets called, and even the start routine that we're writing inside of our class, that's actually called within a loop, where Unity is going through every start function of every component that's in the system, looping through all those and doing everything we want with them. For now, we're not even going to use the update function, so probably not going to do a lot of looping in the first project, right? But it's something you should know about, because we're going to wind up doing loops and fors and so on soon thereafter. Okay. So you have some sort of body of the loop, and the body we usually are defining through our braces here, right? That's giving us some sort of scope, some sort of chunk of code that is going to be scoped to the while statement or the do while statement. And what's going to happen is we're going to execute the body of the loop repeatedly so long as the condition contained within the while is true. That's the case of a while loop. Now you may have a while where you put the condition up front. So while is alive. So if you put the while up front, it gives you the opportunity to check before you run the code at all. Is that condition true? So you could say while is alive, and if you weren't alive, it would just skip everything. So that's while. But then you also have the do while loop, classic do while loop, which ensures that you will run the condition or run the loop at least once. So when do you use one? When do you use the other? Well, if you know you want to run the loop at least once, you can go ahead and do the do while. If you are not sure, if you're coming in here and you're not sure if you're going to run it at all, you do the while. It's a bit of an optimization choice. So if you have some sort of operation that you know is going to happen at least once, and it might happen for lots and lots and lots of game objects, well, then do the do. But it's when you're starting out, sort of interchangeable. So imagine these loops here. They're not completely, incredibly useful in game code because they're just kind of what we'd call tight loops here, right? Nothing is really happening in the game other than maybe some print statements here. So you're not going to have the opportunity to run away from the zombie in these loops. But you can imagine as long as you're alive, we would run through the body here and we'd say, okay, subtract 1 from health and compare it to 0. So the moment that health would be less than or equal to 0 here, alive would be false, right? So you'd enter that state, that phase, Dungeons and Dragons, you'd be unconscious and disabled, but not quite dead because you haven't gotten your 3 death saving throws yet, right? So you're not alive, but maybe you're not dead, okay? So is alive is false. If you still had some health points, it would, instead of setting you to that, it would just print things out and go ahead, run again. And is alive, as long as is alive came into here being true, it's going to run through that basically 10 times, decrementing our health each time until health reaches 0, and then it's going to evaluate here and fall out, right? The moment this evaluates to false, it doesn't bother running the loop, right? So if is alive was false, we don't do it again, we can fall out. Okay, so following through this code now, we're going to say, okay, we want to run this loop at least once because, well, they're not alive. So we want to give them a chance to come back to life. And the first time through the loop, we'll say, oh, health is obviously less than or equal to 0 because it got set less than or equal to 0 up here. So we are a zombie. We're in that kind of in-between state. Otherwise, if health is greater than, or excuse me, if health is less than 10, we're just recovering and we're going to sit in here. We're not going to be alive yet necessarily. But we have another else, so we'd have to go through here. Okay, health is no longer 0 because we're going to, at the very end here, we're adding to health, right? So through the loop here, we're adding to health. We're not alive yet, even though we have some health back. Whoops, even though we have some health back the first time, we have to get all the way to 10 health before we can come back alive, right? That's what's happening here. So health is 0, health is 1, health is 2, and so on. We keep falling through here, and we're going to see that this condition here, that health is greater than 0 but less than 10. So we're going to recover, and eventually is alive is true and allows us to get out of here, right? This is going to happen until we are recovered and alive. So that's a do and while loop. Whew. I'm going to take a swig of my grapefruit vitamin water. Not sponsored, but, whatever. For loops. You can almost do anything, or basically you do anything you can do in a do-while loop, you can actually do with anything in a while loop you can do with a for loop. A do-while loop you can't really do with a for loop. You can't have the for condition at the end. I've never tried that, but I've never seen code that actually had a for condition at the end, so I'm assuming that you can't do that. That'd be interesting. Gotta try that someday. So, but usually we use this for repeating a specific number of times, right? In the case of a do while loop or a while loop, it's generally an operation that is a condition, but not, we want to run this 10 times. We could do that, like in the case of the health one there. We basically ran it 10 times, so it's sort of according to a counter. But usually doing whiles, we're using conditionals for. As opposed to if we want to run a specific number of times, like say we wanted to run this 10 times, we would use a for loop. That's your kind of go-to loop, right? So repeating a specific number of times, it's quite similar to a while, but more self-contained. It has its condition and its operations right there, all within the for. So within the for, we have 3 parts. This first part is an initialization part, which is ended by a semicolon. We have the condition that we check, and then we have the iteration portion. What happens next to see, do we get, after we run through here once, go ahead and do that, and then check again, right? So in this case, our good old loop here, if we said, okay, print iteration, the first time in, it's going to be 0. And it's going to check, is 0 less than 10? Of course it is. So it'll print out iteration and the number. Now, you'll notice here I'm adding a string and an integer, and C# will do the right thing in this case. This is one of those cases where it will just assume, especially because it's a print statement, the first argument here is this string, so it's going to assume that you probably want this I to be converted to an integer as well, and it'll do the right thing. If I just said print I, well, I might have to say print I dot toString and convert it to a string like we had in the notes up above. So this is the basic loop, and the I++, that's happening at the end, so we will see that 0 here. It's not going to start at 1, right? It's going to check that. This will happen 0 through 9 will happen, and then when it hits 10, that's going to say I equals 10. I is 10 less than 10? No. 10 is certainly not less than 10, so that would not happen. So this would repeat 0 through 9, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 times, but starting at 0, right? This particular loop. If we wanted, we could say int I equals 1, I less than or equal to 10. That would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Potato, depends what you needed to do, right? You don't have to start at 0. You don't have to be less than, right? These can be complex conditions. These can be things other than just a simple incrementer, right? But this is the most basic form. This I variable here has to exist before we can do operations on it, which is why it's here. Now, you could even outside the scope of this, you could have had int I up here somewhere in your code. It doesn't have to be declared here, but the nice thing about declaring it here and initializing it here is that it will only exist for this loop, right? So if you say int I and iterate over that, it will only exist in here, right, within this scope, right? So that's a for loop. Be prepared to see some of those and write some of those. It's very similar to a while, but it has those self-contained things. If we wanted to, we could write, you could write for and then just have 2 semicolons with nothing in there, and that would be basically a while loop. Or even here, you could say, well, the equivalent of while is dead is just putting that is dead in terms of that condition, right? So it would have no initialization, no iteration, and we just check that condition over and over and over again. Exactly the same as a while loop. So you can do that. Okay. Now, you may not have, this is one that isn't quite so obvious, doesn't show up in all languages. It's showing up more and more in different languages because there's an assumption. Someone one day woke up and said, you know what? We seem to be using for loops a lot of the time to go through collections of things and process a collection of data. We might have an array, or maybe have a classroom full of students and we want to do something. Basically, imagine I wanted to take attendance. I would say for each student in class, do the following, right? So common operation. And if I know I have all of the students in an array of information about those students, I can then iterate through the members of a collection. This requires some things sort of being set up ahead of time, and you have to do, have a specific sort of data structure that you work with. But this will come in handy. We'll see this happening in things. We're going to use, like in this example here, this is a list of strings. We'll talk about this in a separate lecture where we talk about collections specifically. But for now, just know that this is a collection of player names is this list, right? So we may have zero player names or 100 player names, we keep them in this list of player names. And I can use my for each function to say, well, okay, run through this loop for each one of those, and I'm going to use a bit of this is going to be the shortcut, a little temporary variable to refer to each one of those. So me going through the attendance, I'm going to have a little temporary name for each to compare to. So imagine here, for each string p name, because we just have a list of strings here. So for each of those strings, in that collection of player names, do whatever it is there. Check, are they in the class? Mark them as being present, and so on. All right, so that's the idea of a for each. So as you see those show up in your code, or you want to iterate over a collection like a list or an array, a for each is going to be the structure you use for that. And for all of these loops, you don't have to execute the entirety of the loop. You can do things like say, well, all right, if I've reached a certain, I can only fit 10 items in my inventory, and I walked into a room that has 100 items in it, I may want to collect the first 10 items and then stop the loop, even though I'm potentially iterating through 100 items. So in order to do that, we have to be able to interrupt the loop's operation, right? It's happening over and over again. Oh, you know what? I should make sure. I'm going to go over here. I should pop this window out. I'm going to pop out. And I haven't been checking over here. Why is there before health? Okay, I've caught up, I think. I don't know. I'm double checking on the general over there. Wish I didn't know the, so let's see. Sorry. Questions I wish I didn't know the answer to. Who is yeah, oh my gosh. All right, Yandev humor. Gotta love that. All right. I'm going to set myself back up again over here. Sorry, easily distracted. Okay, so in certain operations, in certain cases, it makes sense to be able to interrupt a loop. So we just did a little interruption here. Thankfully, I can resume my interruptions during class, but occasionally I get interrupted as well. And in that case, the way you interrupt is you basically have a break statement, which causes the loop to break, or if you break it, breaks and never comes back. That's the true, we've lost the intent, we've chased after the squirrel, we've left the room, right? Break is all right, there's something more interesting, the condition was met, we're done. As opposed to the continue, that means stop the current iteration, but continue on with the next, right? The moment I remember in my head that, yes, you're in the room, I can say, okay, continue, and continue processing the attendance list in class, as opposed to going through and then saying, okay, let me check over in here, let me check in there, let me wait to hear from you, and going through all of the checks. I could have a continue statement, which would say, okay, I've got enough information, I go move on to the next element, potentially. So cases over here, imagine, stop the loop the moment you find one of these things that is set to 12. So we're going to process the whole list, find the needle in the haystack. The moment we hit that needle, the value is 12. We have a list of integers. We want to stop if we find the number 12. So that's what's going on here. For each integer in this list of integers, if one of those is equal to 12, print that, you found it, and then break. Okay, so stop. Right, so if you said, okay, if one of the coins among this stack of what looks like silver pieces is a gold piece, all right, we have to compare, and then we'll break when we hit the right one. Or perhaps we want to sort and do something like, well, okay, we've got a whole lot of silver and a lot of gold all within this list, and so therefore we want to put the gold in one and the silver in the other. We might have some reason to say, okay, we've got a loop that means run through, do this operation, and then don't do the operation if it was, in this case, we're saying divisible by 2. So this is process just odd numbers versus even numbers, right? So that's where we have continue, where we want to keep going through the whole list, but skip over certain items potentially, or treat them a little bit differently. All right. So generally, in talking about data, we know now we have numbers. Numbers are a measure of something, their amount of something, quantity. We often refer to them as a magnitude. Some amount is magnitude. If we want to know how far apart things are, for example, we would calculate something called the magnitude of the distance between them. You may have seen a number line, and number lines are pretty simple, right? They just are one-dimensional, and if you had, say, the number 0 and the number 10, you could figure out, okay, what is the distance between those? What is that magnitude, right? So there's sort of operations that we may very well need to do, especially in a game. We might want to know how far apart 2 points are. You can represent that distance as a number. That's a magnitude, right? So sort of the simple operations that... Okay. Maybe we want more. Someone's putting, that's the villain was vector, right? Okay, vectors. Vectors, some of you vectors might be new to you. Everybody knows about vectors these days, or some sort of vector. Ta-da. Vectors in game programming are super, super important. Any sort of 3D, 2D graphics, and so on programming. Someone jumped ahead a slide. Or anticipated, maybe. I don't know. This idea of vectors. All right, so vectors are measurements of magnitude and direction. So by themselves, vectors have no notion of location, though. They are... Sometimes we use them as positions, which sounds like a location. This is going to be a little bit weird. We'll get a little crazy here. But imagine that number line again, where we had 0 and 10, and we wanted to have a vector along that number line. It doesn't have to have multiple dimensions. It can have just a single dimension that would be, okay, in order to go from 0 to 10, we would jump by some magnitude, and there's an implicit direction, right? So it's a little bit kind of crazy in that way. But let's talk about more useful cases in our games where we talk about 2-dimensional and 3-dimensional vectors, right? Why don't I have this slide? We need another slide on here. There we go. This slide should appear really kind of after this slide. This is the, vectors. Vector 2s, vector 3s. We already referred to them a little bit. And unlike kind of our typical built-in one-dimensional data types, vectors, typically we're talking about 2-dimensional vectors, vector 2s, and 3-dimensional vectors, vector 3s. And they'll have an X component and a Y component, or an X and a Y and a Z component. Sometimes we might refer to them as A and B components, or R and G and B components for color. So these vectors can contain all sorts of different things, but it's like when we want to have something to establish multiple dimensions, we'll use vectors. And starting out, one of the main things we'll use these vectors for is direction with magnitude. Right, so we know what direction something is facing and what magnitude is there. Vector structures act as array lists. I don't want to consider that for a moment. Okay, let's not get confusing. All right. So let's just think of vectors as being explicitly having certain components in them, okay? So a lot of the time when we're thinking about an X and a Y, we think about a position, right? A position in our game. 0, 0 is the center of the world, perhaps, in Unity, right? 0, 0. So 0, 0, center of the world, easy enough. However, a vector in its real sense, a vector isn't a position. A vector is a direction and a magnitude, right? So the data structure we're using certainly just has an X and a Y value, so they're convenient for positions. But in order to really kind of comply with the notion of a vector, which is supposed to be direction and magnitude, we would have to assume that that vector had a starting position and that it wound up getting us there, right? If we assumed that the vector was offset from the origin, 0, 0, the center of the world, well, then our position vectors make sense, right? Because they're offset from some specific position. Because we're going to want to use them for movement a lot of the time, consisting of adding vectors together. All right. So let's stop there for a moment And let's jump over. I'm going to pause on vectors. Right. The important thing that we're going to need to know about vectors is that we're going to use them anywhere we need to have an X and a Y. And our games are mostly going to be starting off having 2 dimensions and having an X dimension and a Y dimension. So when the player moves, they may move in X and Y, or they move diagonally. They're going to be moving in X and Y. So it makes sense to kind of think about using vectors for that sort of thing. Now, at the beginning of class, I threatened, or didn't threaten, I guess, talked about this UI canvas. And I want to get back to that for a bit. And we'll go over there for a moment. And then we'll, if we get through my calculator piece and so on, then we'll kind of come back to applying or using vectors within there, right? Because we're going to move on the diagonal, basically. It's going to be the exciting part. All right. So let's talk about this Unity UI, the canvas, right? Buttons and sliders and text. And how are we going to use them really within that one-room text adventure and our new and improved, our calculator example here. So remember that the canvas and UI are the player's sort of heads-up display. It may or may not be Jarvis Fancy or voice activated, but the concept is the same, and you can get to that point. You certainly can develop very, very sophisticated user interfaces using the canvas. You can use graphical elements, you can have them be animated, you can do all sorts of stuff, but we're not going to, start off there. We're going to start off with the basics. So this is sort of, imagine this being your adventure game. You might have a left and a right and an up and a down. So maybe this changes the X dimension when you go left and right, and the Y dimension. Something's really funny. I don't know. I'm totally distracted. Then you have an up and down or forward and backward. You may have an action button. You may have the turn on my flashlight so I can see. And you might have the turn the volume up and down or increase the radius. And if you increase the radius of searching, maybe the flashlight uses up its charges faster. All those sorts of things. And then we might have some text over here. Simple, status and some other sort of story text, perhaps. Right? So that would be similar in concept to our heads-up display. In Project One, we really don't want to, or we can't, the idea is that you can't see the world, but we do have graphical controls and sound to work with, right? So typically the objects we're going to use are, through the Unity UI, buttons, text, toggles, sliders, and perhaps more, more than just one piece of text, because maybe there's like a current thing, you feel healthy, but you move to the left, maybe you want to have 2 different text boxes for that. You likely will have an audio source, if not more than one audio source, for things like the sound that you make when you bump into the wall and the sound of your heart beating as you're wandering around, or the sound of water off in the distance, things like that. And optionally, if you wanted to restart the game, or you wanted to go to a different stage, or you want to go to a different level, we'll talk about scenes a lot more. And ultimately, once you create your lobby and have multiple scenes within your game, you're going to have scenes, right? So you may have that. Now, one of the big changes with Unity 2021 is that you're going to see, let's go over to Unity again, and this one I decided to be new and improved as much as possible. If I've already added a canvas here, so if you right click in here to add an object to your scene, you see that there is this UI group, and these are the things we want to use. Basically, just about everything on here is fair game with regards to the adventure game, right? Everything should be in here. Don't use the UI toolkit. Don't use anything else, just UI. Images, Text Mesh Pro text, raw images, panels, toggle sliders, scroll bars, scroll views, buttons. We won't really focus on drop downs and input fields, but you can use them. And there are the legacy versions as well. Text, buttons, drop downs, input fields, the non-Text Mesh Pro versions. But these days, we're supposed to be using Text Mesh Pro because they're more exciting and more flexible, and we can use fonts, and et cetera, et cetera. So I'm going to do examples with Text Mesh Pro. They're not, the end result isn't that much different if you're just using the basics. So just be aware. Sometimes the data structures are different. Yes, data structures are real. Yes, the fields, the methods, and so on inside of a Text Mesh Pro object is going to be different than they are in a simple text object. And in order to refer to them, we're going to have to refer to them a little bit differently than we normally would. But These are all the things that we have there. Now here, if we look in the canvas, like say I click here and I want to create, I'm going to say UI, and I want some text on the screen, so I'm going to say text Mesh Pro. If I've never used Text Mesh Pro before, I should be aware that it may pop up a little window or pop up a box saying, oh, do you want to import the Text Mesh Pro stuff? And now I'm going to say yes. All right, so if you're opening this for the first time and you're adding Text Mesh Pro for the first time, it may ask you, by all means, say yes. No need to put the examples in there, though, just the basic resources. And we'll get this new text here. So Text Mesh Pro, yep, lots of things we can do with it. The only thing we really want to manipulate, or the things we want to manipulate, we can certainly play with the styles and so on, but you may want to play with, say, the font size, right? Fairly obvious. Go back to 32. And what the text actually is, right? So you see there's a little text field there, right? So the Text Mesh Pro dash text, right? There's a hint there, but we're going to change here. All right. So you might ask yourself, how did I get here? Anyone Talking Heads fans? No? Sorry, bad reference. All right. Okay. So sooner or later, usually sooner, you're going to say to yourself, how do we, from script, interact with other objects and their components? All right. So that's going to be the important thing that starts to happen very quick. And in the one-room adventure, that's obviously going to be important because we're going to have all these potential actions that we want to have then interact with our game manager script. All right. So to do that, to interact with objects on the screens, we're either going to update their components or we may need to react to certain things that become attached, right? We're going to attach methods for our controller scripts to the on event of a UI button. So what does that mean? All right, let me do this. Let me show you what happens here. All right. So let's go in here and we have, I want to put a button in, right? So I've already got some buttons here, but I want to have an even simpler, a simpler button. And when I press that button, I want this text here to change. Hello, I want that to change. So let's go through here. Feel free to follow along. So add a Text Mesh Pro object. First, that's just text. And then we're going to right click and we're going to say UI and we're going to say button Text Mesh Pro. All right. And we'll put this over here. And you'll notice we have a button over here. We can name that button Shock. All right, so that button is now called Shock. Didn't change the text on it, but it did change the name of the object. Now, buttons are kind of special in that a button is a combination of a graphic and its interface and the actual actions that can occur and some text on top of that. Right? So buttons are sort of fancy, whereas text was just text. Right? We saw that, where's that text over here? It's called text. Let's call that reaction. Okay. So we have the reaction box, which right now is just hello, silly reaction. And we have the shock button. All right. And the text on the button is actually contained within that text. So we're not going to bother necessarily changing the name of this object that's basically a child of this button. But we're going to edit it so that it says something different at least. So we're going to come here and somewhere in here, if I drop this down, we'll see that it says button and we'll say shock the player. Any Peter Gabriel fans? It should be shock the monkey, but shock the player. And I'm going to change the size of that by using the rect tool, not the scale tool, because I don't want to change the size of the text. If I use the scale tool, it would be very different. We'd see something like this happen. Don't want that to happen. I want to change the size of the rectangle that is contained. So I use the rect tool for that as opposed to the scale tool. So be careful of those two. Sometimes you get confused. But we have shock the player. So when I shock the player, I want this text to change. So for now, I know all of my functions are in my game manager script. So let's find that game manager script. Okay, the game manager, and we'll open that up. There it is. And I want to write a bit of code here. Okay, and my action is going to be, we call it here, it's going to be public, because I want this to be callable by some other bit of code. It's going to be a void, which means it does not return any values. And I need to give it a name, an appropriate name. So we'll call this the shock the player function, or shock the player method. Right? So this, I want to have this called when that button is pressed. Now the question is, well, what should happen when that button is pressed? When that happens, I want to change the text in the player's reaction box there. Right? So now we're going to start to go a little bit deeper, and we're going to talk more about this interface, but we want to do something. We want to ask Unity, or, well, let's see, let's do it the other way. So somehow we're going to need a reference to the text box that we want to change, right? We want to get a reference to the text box that we want to change. So somehow the script needs to know about that. So I'm going to come up to the top of the text here, the top of the script, and I'm going to say, please give me a reference, and make it a public reference so I can get to it from the editor. And I want a reference to a game object. Public game object, right? And this is the type because it's capitalized. And I'll call it, I can call it anything. Reaction text box. Okay. So this is a reference to a game object. And it doesn't, I don't know what it is yet. It hasn't been assigned. It's just there, sitting out there doing nothing. It's just ready to contain a reference. So I'm going to save that. And here's where we start to dance the dance between the Unity UI, the Unity editor, and our scripts here. Okay, so we have a reference, a spot to put that reference in. I'm going to go back to Unity, and you'll see now, after, it may take you a second, it'll say, okay, recompile. And then it'll put up in here, because it's a public variable now, I have a way to access this reaction text box. Unity does this funny thing, just for readability's sake, where it's putting spaces in the name, which I think is a bad thing, but it does it. But this is the same, this is reference that. And you'll see that there's nothing in there currently. There's no reference to it, because it's just empty. So I know that I want to put that text, I somehow need to reference this reaction box, reaction text over there. So, oh, it went away. That's a pain, right? Well, let's do this. We're going to say game manager. First thing we're going to do, there's a little lock up here, and just this is your friend. This is just a handy thing. I'm going to click this lock, which means don't change the inspector when I come over here and change to a different object. So I'm going to go over and press reaction. You'll notice it didn't change. I'm still referring to the game manager over here, but I can click on anybody. Okay, so I'm going to go ahead and click on reaction and drag it on over here and put it in the reaction text box. Okay, so now there is a reference to this Unity object set up to my script over here. I'm going to uncheck this now so it goes back to doing the right thing, or doing the other thing. I'll go back to the game manager, double click on there, there it is. So now, when this code runs, this variable here, this reference, will be filled in with a reference to that other game object. So I can refer to reaction text box now, and I want to change the text in that text box. Whew. Okay. Now, there's another step we're going to need to do, especially in the case of TextMesh Pro, and we want to talk to the Unity interface, we want to talk to TextMesh Pro, or get at other functions within here. When we created a script, it started off with these 3 lines: using system collections generic, using Unity engine. These are, the basics. But sometimes there's going to be other namespaces. These are called namespaces, or collections of operations, functions, functionality that we want to use. So we need to kind of let the compiler, let C# know that we're going to be using them. So your game manager, you're going to put using unityengine.ui, because we're going to be working with the UI. And if you're using TextMesh Pro, we want to say, okay, using TM Pro. Notice it tells us, okay, you have the TM Pro namespace, and we have the Unity Engine namespace and the UI there, so we're going to be good to go. So remember to add that, or else C# will get mad at you later. Now, once you have those two things, now we can start referring to the insides, the guts of this game object, or the components on that game object. Remember we talked about objects having components? Well, all right. Let's see what we can do. So we have that. I'm going to start typing, and I know, okay, thankfully it's filling in for me here. Okay, GameManager.reaction text box. All right, that's that field. I'm going to hit Tab. That's what I'm going to work with. Now, I don't want to just deal with the game object. Now, this is going to get fancy. I'm going to say dot, right? Because I want to invoke a method of that object, right? Or I want to reference some data, a field on that object. So to get at a reference or get a method or data of the object, I hit period. And it's going to tell me here all the possible things I could potentially do. All the data and all of the methods as well. So what I'm going to ask it for is I want to get a component. Okay, get component. And the component that I'm interested, and now here, if you remember our carets here, right, our little less than equal to, this is our generic function, get component. And what we want it to do, it's going to ask, you know, what type of component do you want to get? And the type of component I want to get is a TextMesh Pro UGUI, user GUI, kind of the UI component, right? That's the component that we added. That's the text mesh there. So I get that component and I say that, okay? So it lets me know, yes, now this is the type, and then I am invoking this get component. So it's going to get the TextMesh Pro UGUI component of this object. All right. And then I can start to access the methods and data of that component. So we're going like down the rabbit hole a little bit here. And the one I'm mostly interested in is just the text. Equals, right? So if I shock the player, I want to change the text inside this component of this object. All right, what time we got? 11:14. So I'm going to change the text to this of this component of this object. And I did it the easy way of saying, okay, to get that object, I just did the drag and drop operation. I'll show you another way to do that as well, which is probably the better way. But anyway, so let's save this function, right? Save our work. And we'll come back up here, go back to Unity. You'll see it'll start to recompile everything, reload. And we'll clear out anything that's in there just in case. And we're going to hit play. And we have our button here. And we'll press the button. And of course, nothing happens. All right. Because this button, well, we never really told the button itself, this button over here, how does it know about the script? All right, so the button really doesn't know about that script. It doesn't know how to call that function just yet. The script knows about this text box, but this button doesn't know about the script. So we have to let the script and the button work together. So let's click on this button here, our shock button, and let's look over here in the inspector. And down here, if you look, we're going to open the button component here, right? The button component is the important one, not the image and so on and transform. We don't care about those for now. The button component itself is the important one. We're not going to change its appearance, but you should see this box down here called onClick. Now, onClick is going to be an event that we can trigger for this button. So onClick. And it starts off with an empty list. There's no action, there's no event associated with this button click. But I'm going to press plus, and now it's going to have some things for me to fill in. So onClick, notice first it says there is no object that you're going to be working with. Well, I wanted to work with an object. I wanted to work with what object? The game manager. So I'm going to come over here, click this, drag this over, and drop that there. All right. Alternatively, I could click here, and this is going to be important. You'll see it's Scene Game Manager, right? Click on Scene Game Manager. And if you see like things like this, scroll all the way down to get that. All right. That doesn't help. This helps. So Game Manager. It's important you want to refer to objects that are in your scene. Don't refer to things that are just assets. You want to refer for now things in your scene, right? This Game Manager is specifically this object in the scene. All right, I'll close this out. So now it says Game Manager. All right, so now the shock button knows about the Game Manager object. However, it doesn't yet know about the Game Manager script, and it doesn't know about, or the Game Manager component script, and it doesn't know about that particular function. So we have to go yet another step deeper. Notice it has a little drop-down field that says no function. I'm going to click on that, and you'll see now, all right, here are the components of that game object. So the Game Manager has the Game Manager script on it, and you'll see the things that we can refer to within that component. And what we're particularly interested in is this shock the player method. So click on that. So now it knows on this button being clicked, we will go to the Game Manager, find the Game Manager's component, and run the shock the player method. So come back over here. Let's save this as we're going here. Save. Press play. And now, right? Now when I press that, we get that ouch. Right? Because the player, this button is calling this action, is triggering this action on the other game object within its component and calling that function, which is then interacting with the text component here, right? So we have an interaction between a couple of different components. We have the reaction text, we have the shock button, and we have the Game Manager, which actually has the script on it, right? So in the example here, all of these things are being referenced by our Game Manager script, right? The Game Manager is sort of the coordinator among all these things, and that's where all the functionality that we're adding just now. And eventually you'll be using lots of scripts, but for now, we want to do everything just within this one Game Manager script. Any questions? Anyone get lost on that one? All right. So that's the basic version of that. So let's hop back over here. So now we attached methods from our controller script or our Game Manager script. Right there. To UI buttons. And we can do the same thing with toggles and sliders and so on. Right? Lots of different options. We're going to use that on click. Now, on click for buttons, but now there may be other things like on value changed. So if we came over here and we had, say, a different type of item, so we'll right click over here and we're going to add UI and where's a slider? Here's a slider. All right. And let's move this slider around here. Put Put it over there. You'll notice that on the slider doesn't have an on click. It has on value changed. And that means you're going to have, it's a single, it's going to be a single thing to change. And if I tried, I want to add this, and I'll go through this. I'll go this way, scene, and let's go back to our game manager. Here, game manager. And you see I could select shock the player, and we'll go ahead and play that. And I'll click here. Nothing's changed yet. But then I slide and I get ouch, right? But I'm not using the value. I'm not sending the value to that, which isn't awfully fun, is it? So we can go a step further, and this is important to what's going on here in how do we know what button is being pressed, for example. You could write a dedicated function for every button, but how tedious would that be, right? When all the difference is you have a button that's 1, a button that's 2, a button that's 3. The value is changing, but the code and behavior isn't really changing. It's just you want that value, you want it to know what is being passed in, right? So somehow we want to have something happen. We want our function to know about that value changing. Okay. So let's go back to our game manager. And in our shock the player, let's say, well, how shocked should the player be? Right? So we can pass in a value to the function to actually print, in this case. We'll do the simple case. All we're going to do is say what that value is. Now, I'm going to save that. And this is a good thing and a bad thing. All right. So we just changed that. Let's see if we clear this over here. Let's press play. Let's try our slider again now. All right. Things aren't good. Shock isn't happening. Ouch plus bang. What did I do? I knew what I meant to do. Plus value. Okay, so we want to have the value. So now if we look at what's going on inside the script here, or inside the interface, let's go back and look at our slider. Now you'll notice it is saying missing. Game manager shock the player. That function is now missing. Now why is it missing? Well, we changed the definition of that function. The moment you change the arguments, you're changing what that function looks like. So you'll see in here, okay, there's shock the player that's past a floating point. That is something considerably different than shock the player with just an int value. So I'm faced with, well, I could say in this case, I'm going to put, all right, let's fix that. Let's put shock the player float. That makes perfect sense in my slider here. All right, so we'll go ahead and do that. We slide this, ouch, 0. I think we're unfortunately rounding it to an int, so we want to, let's see. I think what we should have done is said, let's go back to our game manager. Whoops, I'm on the wrong screen. Go back to our game manager. And to string. Let's see if it'll do the right thing there. So before it converted it, but also converted it as an integer. Oh, it's still getting 0 there. All right. Oh. I almost forgot. Okay. So what's happening? Why is this happening? Why is this being a pain? All right. I feel like I'm doing the right thing. I'm calling the right function here, but you may not have noticed, and I forgot. See up here? Dynamic float or static parameters. So dynamic float means, all right, pass that value, this dynamic value, into shock the player. That's the one function it sees that, okay, I can do that. Otherwise, these are static parameters which can't be changed. So if we look, here's what I should have noticed. Click here. You'll see this box down here, this box underneath here. That's the value that's being sent to it, 0. It doesn't change. I click this and I say, all right, game manager, dynamic float, that box goes away, meaning pass it the actual value, right? It's one thing to say on value changed, but you have to send it to the dynamic version or else it doesn't, it just changes it to 0 every time. Whew, that seems tedious. Why does it make us jump through that hoop? Well, we'll see that in a second. And I should have remembered that because it makes, okay, here we go. Ready? All right. Lots of changes now. Okay. But you'll notice shock the player, nothing happens for shock the player, unfortunately. Because if we go back to the button again, well, it's missing shock the player. So we need to go back and sort of fix shock the player. So we're going to talk a lot later about this concept, this object-oriented concept called polymorphism, or referring to things by the same name. And let's just do a quick example of what that means. All right. In lots of your other programming projects or your other classes, you may have said, well, okay, that has to have a unique name. But watch what I'm going to do here. I'm going to say, well, public void shock the player. Now I've got 2 shock the players. And I'm going to call, whoops. Shock the player 1000F, right? Now I'm allowed to do this. Notice I have a shock the player function here, and I have another shock the player function here, another method. Right? They look very similar, they have the same name, but they have different arguments. One takes a float, the other doesn't. Right? So this is this feature of polymorphism, this way we can have methods within our class that have the same name, so we know, yep, they're both supposed to do the same thing, but one might take a different parameter than the other. So I'm going to save this, and now go back to Unity. And press play. And now shock the player works again. And this shock the player works. So they both work. Because it healed itself when I go to my shock button here. Notice it finds it now. Right? Because that's the version that we told it to call. And it's just calling the static version, and it's not passing it a parameter because there are no parameters to that function. Right? So we have a slider that passed a dynamic value to that. We have the button, which didn't pass any value to that. And then we have the option of things like these buttons over here, which now we're going to use these to do those. Come on, button. Click. There we go. You'll see here on my click, we're using this field that is available on each one of these, this static version here, right? Game manager, and there is no dynamic value. I can't pull the text from there. I just use the on my click, and I need to pass in an int. And that int is going to be whatever this number is. And I have to, if I create another one, I'm going to say Control D, and that's yet another number. Whoa, look at that. I didn't mean to do that. I gotta be careful here. Select the button, Control D, and 3, and we'll call that one 3. And we also have to take the extra step to make sure we change the text to 3. We're not gonna get super fancy. You can do a parsing and things. But anyway, so we've gone to this button here, and we're using this passed parameter, passing that parameter to the on my click. So we now have a 1 button, a 2 button, a 3 button, and they all use the same function, this on my click function, but each of those are going to get passed a different parameter, right? So in our game manager, come on, game manager, we have our other operation up here, our on my click, which is getting passed a value, and the value is going to be handled here. Now, so what's going on inside in our little calculator as we, let's talk about the calculator. We have a little bit more time to do that. Okay. So on my click is the function we're going to use, the method we're going to use for numbers, right? So anytime we press one of those numbers, we're going to use this on my click. And I created this. This is a function or method I created, doesn't exist outside, it's not a built-in Unity method. So on my click, I pass in a value. And I'm only going to allow my calculator, it's going to be real simple. It can only add 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I can't have multiple, I can't have 10, right? I could, but for now, let's keep it simple, all right? So what happens, here's my logic. I know that I'm going to have two operators, or excuse me, 2 operands and 1 operator. Okay, so you can try this one out now. So let's have our calculator. We're going to need 2 numbers we're going to work with. So we're going to have 2 operands, A and B. Right? The 2 things we want to add together or multiply together or do whatever together. A and B. So we have a place to store those. And then we're also going to have an operation. Now this is a little bit fancy down here. I'm going to do this a little bit. We'll talk about enumerations or enumerators here. An enumerator is a fancy type of integer that can only be certain values, right? So if I wanted to, I could have made this just an integer, and then I just would have had in my head, remember that 1 is plus, and 2 is minus, and 3 is division, and 4 is multiply, and 5 is equals, right? See what it's doing here? We'll talk about enums a little bit more later. But our operators are defined as an enum, right? It's going to be one of these values. Right, here's the syntax. Public enum myop for my operations. I'm declaring this type here. This is a declaration of my enumerated type. Right? And it also allows for this empty state here. This empty meaning I haven't pressed an operation yet. Right? There's no operation yet. The moment I press one of the operating buttons, it's going to know what to do. But I might start off with empty. Right, so these are the conditions, the possible operations, and the no operation yet. That's what's going on in this line here. It's like just defining those, just so we know what they are. So I left room, right? For now, plus. I just did plus, but we could have minus, division, mult, and equals eventually. Well, equals we're using. All right. We're really using just empty, equals, and plus for starters. So I declare a member variable, a little member variable here called operation, right? So that's the operation I want to do. And I name it, so it's a public, the type is my op, and it's named operation, right? So we have the scope, the type, and the name, right? This is the variable here, right? This was a definition up here. This is a variable that we're defining, and then we're saying the initial state of that operation, because it's this fancy one that I created, this enumeration, I have to give it one of these values. It wouldn't let me set this. So watch this. Ready? Let's do something crazy. We'll say, well, I'll do this. 12. I can't set operation to 12 because I cannot implicitly convert that int into that type, right? I have to do the right thing there. There's no 12 state, right? So that's the cool thing about enumerations. So I say public enum myop, and I set empty for starters. All right. So the initial state of my calculator is that I have two numbers, a and b, integers. I have an operation, which starts off being empty. Okay. And then the logic. This is how the calculator actually works. We say, all right, let's assume, and there are some assumptions here. The calculator is not guaranteed to work with everything, but I'll let you flesh it out as an exercise, or maybe you want to start jumping into other things. That if operation is empty, meaning I haven't pressed plus, I haven't pressed equals, I haven't pressed anything yet, that means it's waiting for the first variable. It's waiting for A. So I pressed a number, the first number is going to get assigned to A. That's what's happening there. I could maybe, I'll put it up here just to, didn't really matter. So I assigned whatever the value that was sent to A. And I also decided, all right, that text that's up there, my message text, I'm going to set that to be the value of A. That's why I see, the moment I press that first button, it shows up. Now, you remember before we did this reaction text box down here, and we used drag and drop to get that reference to that object. Here's a slightly different way to get a reference to an object without the drag and drop part. There's always multiple ways to do it. So without the drag and drop part, to do it all inside of script, I'm going to do this bit here where I'm going to say, okay, among all the game objects, so I'm going to refer to the game object class, among all of those, please find me one called messages, right? GameObject.find. It's going to look for the one called messages. And over here, you can see that there is, in fact, a text box or a Text Mesh Pro object here called messages. And it has text on it, right? So that's the object that I'm interested in. Now, I could have, if I wanted to, drag that over into a field, but notice I haven't defined it. I haven't defined a field inside the game object. Instead, I just am referring to it on the fly. So this is an alternative to having a publicly referenced or a public reference to a game object within this script, right? This returns a game object. So I could just as easily, if I wanted it, local copy. All right, let's discuss what this is. Or I could, maybe this would be clearer. Right? Now this line looks a lot more like this other one down here, this reaction text box .get component, because I used GameObject.find messages to get it, right? So that's just a way of getting a reference, and here I'm getting just this little local reference to that game object. And then similarly to how I did it down here, once I have a reference to that game object, I need to get a component reference to its Text Mesh Pro UGUI component, and then set the text of that component on that object to be the value that I just passed in. Right? So that's why whatever the number is, that first number that I pressed shows up in that message and also gets assigned to A. Right? That's what happens. Now, the moment that if operation is not empty, that means, all right, at some point already I have pressed operation, or I've assigned something to operation. So operation, that's the operation I want to do. So I have a different method that happens that I can assign to operations here that are going to say, well, all right, public void on operation is passed a value, and what I'm doing here is I'm casting. This is a special thing called casting, which allows me to do this comparison. I can compare an integer to my enumerated type. Right? Remember, I defined my types for my op up top, and 1 is plus. So we say, okay, if you press the plus key, that's basically what this is saying. If you press the plus button, that's what that line is. Okay, so if you press that, set the operation to plus, and what we're doing here is we're using this plus equals, right, or combined assignment. So we're going to add this little bit of text to whatever text is already there. So if we already have a 1 there, or we have a 1 plus 1 there, we have a 1 plus 2 there, whatever, it's going to go ahead and add another plus. So we're now kind of primed to be in the addition state here. We know the operation is going to be this, and we're going to put a plus on the screen. So that's if it's plus. Then we have an else. So the only other button we have right now is the equals. So I kind of shortcutted it here and said, okay, if you didn't press plus, you must have meant that you want to press equals. You want the result. So this means anything other than plus was pressed. I go through this step and I say, all right, now set the text to, and this part's the little funky part here. Notice it's going to print out, and I'm going to do a little message here. This leading string here just kind of cluing it in the fact that it's a string that we're going to print out. So we're going to say empty string, whatever the value of A is, and then we're going to put plus an actual plus in there. And then we're going to put the actual value of B, and we're going to put it equals. And then we're going to put this operation at the end, A plus equals B, right? So A is now going to contain A plus B, whatever A plus B was, right? So that's the result. So if I wanted to be more specific, just in case, I'm going to add another type of operation. Right? Equals is legit there, right? So if it's equals, do that. Whoops. Gotta be kind of careful. So if we press the plus, this is what happens. Otherwise, we check to see if we pressed equals, and if we did, show the results of the operation. Let's save that. And let's go back and watch the behavior and see what might happen next. Now, this will be the challenge. We'll do a real quick version. 1 plus 3. So at the moment I pressed plus, it knew that, okay, there's a special case. And then press equals, okay, we got 4. Plus 2 equals. 4 plus 2 equals 6. Changes on the equals. So let's as an example, I'm going to now, instead of just adding a new number, because adding numbers was pretty easy, right? I just needed to say, is it the first number, is it the first operand, the second operand? Let's do something more exciting as part of our example, and I'm going to duplicate the addition, and instead, I'm going to change the text on this button to be minus, right? Way more challenging. And I know I have to remember that minus is 2, right? So let's save this, and then we'll think about what's going on. So we have plus and minus. We have our numbers. Minus, if I look in my game manager, my script here, there's minus, and if I float over it, yep, my up minus equals 2, right? So plus when I pass it a 1 value, minus when I pass it a 2 value. And now, all right, do we have to change the first part? No, because this just does the assignment, right? So this is just the assignment. It's the operation that we have to change. All right. So what we need to do is potentially 2 things. So first off, we have another case here, and I'm going to leave it to you to say what, if you wanted to actually put a switch statement in here, but well, I'm going to do it the written out way. So with first case, plus button was pressed. Now I'm going to say, all right, minus. The minus button was pressed. And first I'm just going to change that. But now, let's see, you got to change that too. Right? So the operation changes to minus, and I show minus in there. And I also have to decide, all right, I've got 2 different operations that can potentially be happening here now. So my if statement is going to get fancier now. And I want to say if operation equals my op, what? My op plus, and I'll do this. Right, we're doing the plus operation. Else minus. And we'll do the minus operation. And the only differences are going to be this minus here and that minus there. All right, let's see if that works. And then we'll look at the code again to make sure. No sense reviewing code that doesn't work. And then we'll wrap things up at that. All right. Okay. So we'll say 3 minus 1 equals 2 plus 3 equals 5 minus 1 equals 4. Now we can't do plus 22, right? Because it only can keep a single number, right? So where you go next with it is sort of up to you as a sample, right? So I'll kind of, nothing changed in here. Just to wrap things up, nothing changed because we just have a single integer at a time. And the main complicated part, and it can be simplified, is that this state becomes a little bit fancier, right? We want to say, okay, if plus, we have to set the operation that we're going to do to plus and show the user that. If you pressed minus, which is the value 2, then you do this and you kind of set up. And then ultimately, if you press equals, you have to do the plus or the minus operation, right? And this could be replaced with a switch statement if you wanted to, right? Even this part up here, a lot of this could be a case and a switch statement if you wanted it to. All right. So that should give you a good exercise to kind of play around with in terms of, you know, getting used to connecting things to the Unity UI, and then potentially, you know, how would you use them? How would you assign values and so on? And ultimately in here, I'll give the next hint. We'll talk a lot more about this. You could have a vector to player position. And imagine when you move forward, you're going to be manipulating player position, say, position, player, why can't I type position? X or Y, depending on where we go in there. I'd have to define it. Okay, we'll talk more about the vectors and how they factor in. So we'll actually kind of start building out the movement next class. All right? So hopefully that gives you a good running start with the Unity UI and how to kind of hook things together and how to play around with some of the operations and really understand the ifs and thens and the operations. All right. If you have any questions, please do post them on Discord. Otherwise, I'll see you next week. I'll be around office hours. My office hours are normally between 2 classes, so I'll be sticking around. I'm going to have a little time for lunch. You all go. Have a great weekend. Okay? All right. I'll put up the recording. You too. Hello. That is all. If you have installed everything through Unity, and if you installed Visual Studio through the recommended methods in there, it will automatically do the formatting and the all the syntax highlighting and auto completion. So you want to install it as part of the Unity install. Now, if you've already installed Unity but you didn't install the Visual Studio there, you should have still have the option within the hub. What do you mean by the button click stuff? Right, that would still all work, but not necessarily be like you could even if you had your editor set up as Notepad, that would all still work, right? It's a deeper level of integration that does the actual code completion and has all the templates for C# and Unity, so it can find all the definitions for that. So the thing you want to double check if you go to your installs, and like in my case here, I went to here. I think. You can add modules and make sure that Microsoft Visual Studio Community 2019 is installed there. Okay, let's try one other thing then. So inside of Unity, we'll go back to Unity over here and go to Edit, Preferences, and you'll see External Script Editor. Under External Tools. So you go to External Tools and see, does it say Microsoft Visual Studio or are you choosing? Okay, drop this down and hopefully, do you see any other options? Click on that one, yeah. Otherwise, if you say open by file extensions, just using whatever code editor that you told it you had, which is probably Visual Studio Code or Yep. Yeah, no, I use others as well. I used to have Atom in here. I occasionally use Rider. But to get all the kind of the default features, you just want to, for starters, 2019, way to go. And that'll help with debugging. We'll use the debugger in there and definitely code editing and highlighting it's useful for. to get a good feel for things. All right. Cool. Okay. Great. Have a good weekend. No problem. Okay, let me. And did I check you as far as which? So your what's your name? Margaret. Oh, okay, okay. Yep, got it. All right, awesome. And if you do need to, refer back to watch the beginning of the video, or just to catch up. I don't know how much of the class you missed. Okay, yep, a little bit of stuff to cover. Okay. All right, you two. Jade, is your window just open, or you have a question, or? Which one are you? What's your? I see Jade. I don't see. Okay. Yep. No, I didn't mark you as anything. I don't mark anybody as anything until I'm sure. So, okay, great. Thank you. Take care.